Okay, so we've been talking about the minerals way back when. We talked about some of the characteristics in that minerals. Now we're going to look at mineral families. So this is a way to classify or organize the minerals. All right. So the first family, and some of you ran into this when you did your posters, are the native elements. Those are minerals that can actually be found as a pure element. So instead of having different true chemical formulas, they're just going to be the pure elements, so they will have a symbol instead. Doesn't mean they're always going to be found this way, but yes, they can. So we have copper, silver, gold, sulfur, and carbon. And carbon can take two different forms. Carbon can either be in the form of graphite, like what we use in our pencils, or carbon can be in the form of diamond. So that's kind of an interesting thing about carbon, two different forms that it can take. Okay, the next family are called the halides. Now when we get into chemistry next year, you'll see this again. Because the halides are compounds of what we call the halogen elements. So it's a particular group of elements. One you'll be familiar with because of what it makes. These are something we call, precipitates. And I think of precipitation to rain down, to rain out. So they're going to solidify out of solution. Best example, and where the name comes from, halite, rock salt, sodium chloride, table salt. All right, so a very common one. Now you can say, hey, pass the halite. Family will be looking at you like, what? Halite. All right, so native elements, halides, oxides. So these have, they're very hard and dense. They are ores. Now, what do we mean by an ore? An ore is material that you can get other valuable minerals, elements from. Okay, so it's kind of a group of things. All right. So you might have an ore, an oxide ore that has aluminum in it. So you can extract the aluminum from it. Ice, remember we said ice is a mineral, okay, because it met the three characteristics. It's natural, it's a solid, and it has a regular crystalline pattern in it. Which I need to be careful saying. It also has a specific formula. Because there are some mineral, we'll go into that later. Iron and tin. So these can all be found in these oxide ores, and we can extract those from there. Oxide. What's another element that's going to be found in this particular family? Well, it's given in the name, oxygen. So they're going to have oxygen in their formula. All right, do you also notice on these family names, they tend to halide, oxide. Our next one is sulfide. So what are the sulfides going to have in them? Sulfur, right? Again, the sulfides can form ores, and from those ores we can get copper, lead. That's one of our Missouri ones. Zinc, silver, and iron. All right, now, the sulfates. Well, we know it's going to have sulfur in it. And when you get into chemistry next year, we'll talk a little bit more about some of these endings and that. But sulfate, 8, means that there's an oxygen in it. There's oxygen in it, okay? So sulfate, SO4. Example is gypsum. We saw it, we'll pull those out. We'll pull all these out again, our examples, and look at them again with the families. The carbonates. So we know 8 means there's going to be some oxygen in it. Carbo, carbon, carbon. A couple examples, calcite and dolomite. We'll be talking about those, especially since Missouri here. The silicates. Well, we know we got the oxygen and silicon. So silicon and oxygen plus a metal. So a little more complex. What's neat about these guys is that they are 90% of the rock forming minerals. So you go out, you pick up a rock, especially around here, chances are pretty good it's going to be from this family. You have a 90% chance. Now there's a couple different versions on your silicates. There's something called ferromagnesians. Ferro refers to iron. Magnesium. So it's telling you that these are two of the elements that are going to be a major force in the characteristics of these type of silicates. They are sometimes, instead of using ferromagnesium, sometimes they're called mafic. So either term you can use. Like I said, iron and magnesium, which is in the name. These particular silicates are darker in color and they're dense. They feel heavy for their size. Now, dark is kind of a strange term here because what geologists mean by dark isn't necessarily what we would refer to as dark. Most of it is, but some of the colors, like some of the reds and that, which are, could be darker, we're going to have to practice on that one. But overall, think dark and dense. Okay, a couple examples of minerals that fit into the ferromagnesians or the mafic are olivine and biotite. We looked at olivine. If you go back, remember olive, it's a greenish color. Biotite, we saw that was that thin black mineral that we looked at. And we'll pull all these back out again. Well, what I like about the earth sciences is they're very logical in how they name things and that. Well, if we had the ferromagnesians or the mafic, which were your dark, dense minerals, then the non-ferromagnesians are going to be the opposite. Very logical terminology here. So you can use non-ferromagnesian, or you might call them felsic or sialic. I've heard both. I think sialic gives you a little bit more information here because of the silicon and aluminum, which are your main elements within these minerals. They are going to be light in color, and they are going to be lighter in density. They're going to have a lower density, so they're going to feel lighter. Okay. A couple examples: feldspar, and then quartz also. Okay, and some people are like, well, wait a minute, quartz? You can have smoky quartz that looks black and yeah, but in general, quartz is considered a light mineral. All right, let's see, what else do we have here? Okay, I think we'll just end for the time being with the families. And then we'll talk about how minerals form and their uses and reclamation of mines and that a little bit later.